Yeah.
From 7 page 445, number 7.
All right, guys, this is page 444. This is 7-2, number 7. So, we talked a while back about, when you make a fraction, what's called a rational expression, you put two polynomial kind of things on top of each other. Whatever you could do with fractions that have numbers in them, you have to be able to do the same stuff with if they have variable expressions in them. So one thing you can do is just straight up reduce them. But if I have, 2 in a row multiplying, what do I try to do? Number 7?
Yeah.
This one here?
Eliminate stuff.
7-2?
Yeah. 7-2, number 70.
7-2, number 7.
70. 70.
Oh, 70.
Yes.
All right. So this one's going to be the same kind of idea, just a little bit more involved. Real quick, since I wrote this up here, what would you do?
I flipped the right one and eliminated everything.
Why would you do that, Carl?
It looks easy from here.
It looks easy.
It'd be wrong, right?
What's the only time you flip the second dude?
Divide it.
Yeah, if you divide it. And right now this is multiplication. Cool. So don't just multiply across. This problem is slightly evil. I don't know why they did this exactly, but what's the only part of this you could really factor? Yeah, this guy. And how's it factor? How does it factor?
N minus 2 and plus 1.
Does anything cancel?
No.
So the only answer when you have nothing that cancels is you just kind of slap everything next to each other. So the answer would be this times this over this times this times this, right? Because nothing cancels. But don't waste time multiplying it back out. Leave it factored. There's no reason to multiply back out. It's just a waste of time right now. Kind of depends on what you want to do next, and we don't want to do anything next yet. So,
Would you factor the left one also?
why can't you factor this really? Using real numbers. It's a sum of squares. So the same reason I can factor difference of squares, it allows the signs to be opposite, so they'll cancel. This one wouldn't allow the signs to be opposite. The middle terms can never cancel. So you can never factor a sum of squares.
Oh, yeah.
Cool. All right, so let's look at the real problem, number 70. So number 70 is almost the same thing. Carl, I think you just had some ESP earlier or something. Because this one involves division.
Is that plus 5x?
What
Yeah.
section is this?
7-2.
7-2, yeah. Now, I want you to realize on one level, and I said this before we got into chapter 7, but the more you understand factoring, the easier chapter 7 will be. So this problem starts off as 4 factoring problems. Do you guys see what I mean when I say that? So, it looks like everything is probably factorable. So there's 4 factoring problems. I've got this division symbol, so what do I do, Carl?
Flip it.
Good. You flip the second dude, going to multiply it. So division is not different from multiplication. So you just start attacking it. So where'd you have some trouble? Do you guys remember how to do cubes?
The bottom.
Oh, this here?
Factoring the
first second.
yeah.
Yeah. First denominator.
Yeah.
Oh, this guy?
Yeah.
Okay. So let's start Let's start here real quick, and then we'll do that one. So what do I put down for this guy? For cubes.
X plus 2.
A plus B plus A squared.
Nobody ever wants to say what I want to say.
Yes, I was gonna say.
I got it. So and the little dude goes.
X.
Yeah, because this is x. This is 2. y, 2y, 2y. Cool. So then the little dude gets,
X
and what goes in the middle of those?
plus
Plus, the same sign, I love it. The big dude gets, careful,
X squared.
x squared
Minus
minus
Oh, it's
4.
X,
2y.
2y, or 2xy, or however you want to put it.
Yeah.
And then the last dude's going to be
The rest.
4y squared. Good. So that's how you build cubes. People normally don't like that as much because you can't sink your teeth into it. You just got to remember where everything falls. So this is the one that gave us trouble?
Yeah.
All right. What procedure do I use on that? What do I do? What's that first number?
Sure.
Yeah, surefire.
Sure.
Or however you want to call it, master product, whatever you want to call it. So what does that mean? What do I do?
4.
Yeah, 2 times 2 is 4. The only factors of 4 that make 5 are 4 and 1. Yes.
So the only thing that confused me was the middle term is XY.
But watch. Here's the beauty of surefire method. Ready? And I'll show you something else. I'll do another one like this that I wouldn't even use surefire on, but I'll show you how to do it. So it's got to be 4 and 1. Are we all cool with that? Mm-hmm. There's not many ways to factor 4. So then I can rewrite this as 2x squared.
It's 4 squared.
Oh man, well it's probably better than it is. Plus, yeah, exactly. So you use these numbers to break the middle dude down, right? 5xy is 4xy plus 1xy plus 2. You don't need that 1, but I just put it there because it stops. And then you just do what on the bottom? Group. So the beauty of surefire method is if there's extra letters in there, it kind of, as long as it'll work, it'll make sure they end up in the right place. When you group, everything's going to fall in the right place. So what comes out of these first two? 2x, and you're left with
X plus 2y.
what comes out of these next two? Y. X plus 2y, yeah. So how do you know you can do the next step?
Because they're the same.
Because these two are the same. A lot of you guys in the homework, you're getting a different thing here, but you're somehow doing the next step. You can't do the next step unless these are the same. Because the next step is pull this dude out. Right? So now the top here is done. I know we got this whole other thing over there. But this is the only question about this problem. I'll just do this part. And the bottom we've got x plus 2y times
2x plus 1.
2x plus y. I love it. So if I take this out, I'm left with 2x plus y. And you can already see something that's going to cancel.
X 2y.
Yeah. Now to keep going with this problem, you would multiply by, and you factor that down, right? The most important thing not to do on this problem is to just think you can just kill like a couple x's here. Why couldn't I do that? There's 3 x's here, why can't I just kill 2 of them?
Sounds good.
Please tell me you can't do it. Why can't you do that?
You said so.
No, it's never good enough.
Oh, because the powers are.
No. So let me write a little easier for you to look at. So if I add x plus 3 over x minus 3, why can I not kill
Oh,
it?
Because they plus
They're not like terms. They're not like terms
the
either.
sign.
What operation is happening on the top and the bottom?
Addition.
Addition and
And when you're trying to cancel addition and subtraction using what? Division. Will that work? Is division the opposite of addition? Exactly. You can't break into an addition problem with division. Division is not that strong. Now, if I had 3x over 3, what can I do? I could totally do this. Why?
Because 3x multiplied.
Yeah, division is the opposite of multiplication, so of course it's going to cancel. So don't make that like a big issue. The reason that we don't have that problem with numbers is you would never see this expression with numbers. Because if it's 7 plus 3, what am I going to write there? 10, because I know what it is. So it's only variables that are going to have that addition show up. So we're not used to not being able to do that. But these aren't factors. This is addition. Division can never kill a part of that. Now, why can you do something with this? There is something you can do with that. You can't just cancel the 2 out.
you can separate.
But you could take a 2 out at the top. what happens then?
X plus 3.
So now you have 2 times this over 2, so of course those are going to cancel. So be real careful about that kind of thing. You can't break into a subtraction addition problem. Everything's got to be multiplication. That's why the first step on these problems is factor, because then you're making everything something times something, and they're ready to die. Right? Same thing, top and bottom, kill them. Yeah.
Is that because the 2x plus 6 is all one term at the moment? And then,
Well, they're 2 terms, and they're both being divided by 2. So another way to look at this is, if I do this, that's not fair. How does 6 escape being divided by 2? It was on top of 2. If you cancel it out, how did it escape? That's not fair. So you can see they both have to give a 2, and then it cancels. So they're both changed. So another way to do this problem is, this is 2x over 2 plus 6 over 2. And you still get x plus 3. Okay, so it's just because we have a division and we have addition and subtraction, you cannot cancel parts of that out.
beautiful.
Thanks, Carl. All right. So anything else from homework? I got a couple questions from online, and then I'll come back to you guys. So I'll do these 2, and then I'll take maybe one more question. So one of these, who gave this to me? Where are you at? Is it 12V? I don't have much room to talk about it. Go ahead, Ryan.
Yeah.
That's 12? Okay. Okay. Oh, so you...
There are 3.
Okay, good. Gotcha.
What number is that?
This is section 7.4. It's number 14 online. It's not giving me the exact same problem.
I'm online, that's fine.
Oh, good. Okay. So like you said earlier, everything that numbers do, variable expressions have to do the same because they're really just numbers I don't know yet. I can't put together these fractions until I have what? LCD. For some reason, people kind of forget that and you start putting them together. But none of these have the same denominator. But what's really nice about this guy versus those guys? What's he got? What can I do with him? Different squares, so I can factor him. See what he's made of. See what everybody else is missing that he's got. So how do you factor this dude?
B plus 5.
Not surprisingly, you factor just like that. So a lot of times these problems are going to have hints in them. It's kind of nice. You look at the other bottoms to get hints as to how to factor the other stuff. So he's got a lot of stuff. What's he missing?
V minus y.
Yeah, he's got a v plus y. He needs a v minus y, so he'll be the same as him. Remember my kids run around. He's got more ice cream. Will he give him more ice cream? I don't have any kids, by the way. It's probably better that way. And then the last dude is missing v plus y. He's got the v minus. He needs the v plus. My hand won't write the v. It's not used to write the v. Does this guy need anything?
No.
But I still have people that sometimes give him stuff. He's got everything already. The only reason you multiply somebody with is he's missing something. He's the guy that had everything to begin with. He needs nothing. Right? Don't give him anything. So now what happens? So now now what am I allowed to do now? Since they all have the same denominator.
You have to You can add.
So so if I had a quarter of a dollar, and I found an eighth of a dollar, I would wish that I could just cancel the bottoms and I got $3. Yeah, magic, boom, boom, boom. They become bills. So the only time you can cancel is if you're allowed to multiply. You're only allowed to multiply if you have 2 sides. So one way you can do that is if you have an equation, and the other way we saw last time with one of our favorite topics was the fractions inside of fractions. I was allowed to multiply because I got a top side and a bottom side. You guys see that? That runs throughout all of mathematics. I can't get rid of the bottom, so be careful. But what will the bottom be? B plus Y. And what can I do on the top? Combine them, yeah. So I get 12B plus. What do you have to be careful about there? Yeah, minus 6B minus 6Y. Everybody, and one thing I told you guys, you can make this plus and negative if you want to, right? You can see it better that negative's got to go through. So minuses find ways to mess us up sometimes, as we know. And now the last thing is just, what can I do now? Why did I distribute all that stuff?
I'd like to.
Get my like terms. It's just clean up. So 12B, 6B minus the B. The 6B's go away. So I get 12B. What happens with the Y's?
You gotta add 12 minus 12y.
Beautiful. Minus 12Y over this stuff. And what's the last thing you check when you're working with fractions? At the very end.
Reduce it?
Yeah, you see if you can reduce it. Now what would that mean with variable expressions? What do I have to do to see if I can reduce it?
If it's factorable?
Factor it. And what part of that can I factor? The bottom's factored already, so it's pretty much the top. We'll take out.
What do you see now?
I figured that much. I was like, I started thinking, did my V's look like Y's? I know I write bad, but over this stuff. And of course, what happens?
Bam.
So this whole disgusting thing becomes 12 over V plus Y. The kind of, now, I don't know, no matter if you like math or not, it kind of feels good. You took this big thing and you made it back. It kind of feels good, right? Feels really good for me, because for geeks, we're like, yeah. And if you just say it does, maybe I'll move on. All right. It's like next topic, Jeff. Sure, Jeff. All right. And the other question, real quick. You'll get some of these, and they look different than you're used to. So that's one reason why it might be hard. But if I had this is number 4. I guess it's the same section. So it's definitely looks a little bit different from that. It's exactly the same idea. What's the first guy missing that the second guy's got? R. Yeah, good. He's missing an R. He's got 2 R's. He's only got 1. So you give him another R. R. And of course, the top is 2 terms. You got to be careful when you multiply by that. You got to put parentheses around. Yes.
In the bottom isn't a W also? Because the W's.
Yes.
He's got 2 W's, so he's not missing any W's.
Yes.
Good. The other guy. Let's talk about him now. What's he missing? He's got W.
Yeah.
And if you think about it, it's exactly what you do with numbers. If I had 1/3 minus 2 ninths, you would give the 1/3 a 3 on the top and bottom because he's missing another 3. The guy's got a 9. He's got 2 3s. You're going to give the first guy another 3. So you do exactly the same thing. So what do you get at the top here? Good. Good. What's going to be in the bottom? Beautiful. R squared, W squared. That's what they both have.
You got to factor that whole thing?
Not yet. Yes. Combine like terms. So where's the like terms? WR and 8RW. So what do you get when you put those together? 9 or RW, either way. Can you factor that? Are there factors of 1 that add to be 9? Let me know if you find them. There's no real numbers that would do that. Actually, there are real numbers. They just don't look nice. Right? Yeah, so that's where we can stop. Is there's no way I can break the top apart. And there's no reason to either, because the bottom is just R's and W's. The only way anything would cancel is if this guy had extra R's and W's. And does he? Can he get an R out of all this? No, because he doesn't have an R. He doesn't have a W. So I know I'm done. Okay. All right, maybe one more question, maybe. Yeah.
It's the same thing.
Oh, good. Yeah, thank you. I meant to do that from earlier. All right, here's that. That's perfect. And then we'll get into some new stuff. Now, real quick, what would you do with this? What would you do with that? How would you factor that? Yeah, it's got to be 1 and 1. It's the only way to multiply by 1, and they add to be 2. X plus 1, X plus 1. Now, why'd you put an X there and an X there? Why'd you do that? Because there's X squared. So look at this guy. What do I put here and here? Like you just did, X and X, because that's X squared. What I gotta put at the end? Y. And now I just step back and look at the coefficients, make the numbers work. So this is a 1. Factors of 1 that make 2. 1 and 1, see, it's the same exact problem. I just took the y's out of that dude, right? So x squared is xx, y squared is yy. The middle term is going to be xy, xy. That's why it's xy.
So it's 1, 1.
Yeah, so it's x plus 1y, x plus 1y.
That's your answer.
Kick ass. You guys see that?
Say that one more time.
One more time.
About the 2.
Different problem.
Get rid of the 2 x squared.
Well, because it's 1 plus 1 is 2. That's the same reason we put 1 and 1 here, right? 1x plus 1x is 2x. We didn't get rid of it, it's just in there.
Just broken apart.
So if I had a squared plus, what you got, Jeff? 8ab minus 20b squared. So the very first thing you do, so you don't forget it and just get it out of the way. Yeah, you put a, b. That gives you your a squared and your b squared. Now what multiplies by negative 20 but adds the 8?
10 and negative 2.
Yeah, exactly. 10 and 2 make the 2 negatives, so it stays positive 8, right? So it'll be plus 10 minus 2. You guys see that? Mm-hmm. So don't make a big deal when there's an extra letter. As long as, see how there's an a squared and then there's an a? Mm-hmm. The middle term's got to be half the degree of the first for this to work. Same thing for the b. There's 2 b's at the end and there's 1 b in the middle. So it's half the power in the middle. So you know it's going to work. Yes, sir?
Let's say, for example, a squared had a number in front of it.
Then you'd have to do surefire. And the nice thing with surefire is the grouping puts everything where it's supposed to go. You don't even have to think about it. That's the problem we did earlier.
Yeah, okay, so let's say if it was like 4a squared, you just times it by negative 20, pretty much? Negative
Exactly. You do all that whole process. You don't even have to worry about the extra letters. Okay. Surefire will put everything in the right place if it's factorable. Right. Cool. All right, so we're going to get into some new stuff. We're going to do a little bit of review of the last thing. Because I know it was definitely our favorite thing. So let's do some more. So I want to show you an example, a relatively simple example, just to show you the 2 different options you have for how to do these. Remember, there were 2 major ways to do these problems. So if I had something like that's a 4. 4 is probably not the best choice of number. Alright, so the most direct way to do this, the way I think I showed you first, is since I have a top and a bottom, there's one big fraction in here, right? So this fraction has this on top and this on the bottom. What are you allowed to do to the top and bottom of a fraction? Multiply or divide. Right? So in this case, what would be smart to multiply by? 4. So if I multiply the top by 4 and the bottom by 4, why is that really nice?
4 goes away.
4 goes away. And then I'm left with cool. The second major way to do these kind of problems is to realize this says this fraction divided by this fraction. So then you can do what? Multiply by the reciprocal in this guy, right? So let's real quick do that and see if we get the same answer. If we don't,
Is that done? So that's done right there?
yeah, why do I know it's done? Not just because I circled it down the teacher, but why?
You can't reduce.
Why not?
There's nothing.
Yeah, this has got 2y, this has got 1y, so it's not even a possibility it's a negative, but both signs aren't different here, are they? You can't factor this. This isn't there. I'm done. I can't really do anything else. And this is where people feel like they have to do further, so they start canceling the x's and stuff. Can't do that. So another way to do the same problem is to take x plus 2y over 4 divided by this means x plus 2y over 4 what? Times.
4 over 1 minus 2.
So of course here you can see the 4 is going away, so you do get this over that. Same thing we just got.
That looks easier doing it that way.
Either way you want to do it. There's some problems where that's easier, and then I showed you some problems the other day where it was actually easier to do it the other way. But if you like one way definitely more than the other, you could always do it that way. So an example of one that was, I thought, easier definitely to do it the other way was if I have, more than one fraction on the top and the bottom. So something like 1 over a minus 2 over a squared b over 3 over b plus 4 over ab. So let me show you a slight difference in the way I think I did it last time. What would the LCD be between everybody? Yeah. The most B's anybody has is 1, and the most A's anybody has is 2. So this guy actually is the LCD. So what is he missing? Yeah, another A and a B. We do this in a different color. So he's missing another A and a B. What's he missing?
A squared.
Yeah, he's missing A squared. And he's missing
A.
just one more A. How we doing so far? I've got everybody to have the same denominator. So now it's a lot like this dude. Here everybody had the same denominator, so I just multiplied by it, right? So if I multiply top and bottom by what? All the fractions inside will die. What can I multiply by?
A squared b.
A squared b. If I multiply by a squared b, that cancels everywhere. Bam, 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 bam. Let me stop right there and let you guys. So see, if you write it next to everybody, because if I multiply the top by it, I would immediately distribute it, right? Because there's 2 terms up top. So might as well just go ahead and write it next to each one. So you can do it this way, and what do I end up with if I do that? I get AB minus 2 over 3a squared plus 4a. Now, if you wanted to do it the second way, you would actually have to put these together, then write this division, then flip the second dude, and then cancel stuff. And that's fine. Nothing wrong with that. Just personally, that's more steps that I think is necessary. But if the other way makes more sense in general, you could always do it that way. So
Can you show us that way?
just for...
Yeah.
So the other way to do this, so this is done here, because nothing really will cancel anywhere. I can't factor the top at all. So I know it's done. If I take what I've got right now, so I've got AB minus 2 over A squared B. Let me stop right there. Can you guys see that from the top? We made all the bottoms the same. So the second way wouldn't do this. It wouldn't multiply by that. It would just combine these into one term. So I can do AB minus 2 over this because they're the same bottoms. What do I get in the bottom? Yeah, 3a squared plus 4a over that LCD. And then you can write this division as multiplication. So it'd be AB minus 2. It'd be this dude times
A squared B.
the reciprocal. Then you can see that cancel. And you end up with the same answer. Right? That on top, that below, same thing. So please like one of those methods better and do it that way. Or you can do both depending on what the problem looks like. Sometimes one way is easier, sometimes the other way is easier. As long as one of those methods makes sense, it's good. If neither one makes sense, come see me. All right, so I want to get into section 7.6. So the main thrust of Math 90, Math 103, a big part of those would be learning to solve all these different kinds of equations. So later we're going to talk about roots, radicals. We're going to learn, part of what we'll learn is how to solve equations that have those in it. Because equations is how we model things that happen in the real world. And that's, if I can solve the equation, I can figure out what the temperature's going to be tomorrow. I can figure out how many widgets I got to sell to make the most profit, so forth. So, reminding you about something you should have already done would be a problem like this. Which measure? Yeah, sure. So this, you should have seen this kind of... That's all right. You should have seen this kind of problem before. If you don't remember, it probably is just bad memory. But what could I do? I don't necessarily want to work with these fractions. If you wanted to, you certainly could. There's nothing wrong with it. You can subtract the x over 2 over there, get LCD. But since it's an equation, and I'm allowed, it's legal for me to do the same thing to both sides. I've got two sides to work with, right? What's a smart thing to do, since what makes this problem ugly is all the division that's happening? What do I want to do?
Don't you do this one down 16?
Okay, good. And then I'm allowed to multiply by 16.
Yeah.
Beautiful. I love it. So what's he missing that he needs? He needs an 8. And he needs 2. So now it's 8x over 16 minus 6 over 16 equals x over 16.
Can you just multiply it by 16 and then, like...
I'm going to show all the steps. Right? Sounds like you know how to do it. Great. But now that you've got everything with the same denominator, since it's an equation, I'm allowed. And unfortunately, when students see this, you realize, you go, oh, I can kill fractions. Kick ass. Every fraction you see, you try to kill. But the only reason I'm allowed to do this is because it's an equation. Whatever I do to one side is balanced by doing the same thing to the other side. So then you end up with 8x minus 6 equals x. And that looks really, really nice. That's much better. Cool. Yeah.
Silly question.
Okay.
Once you got the LCD and got the equal sign, why do you go through all the trouble of writing a 16 up there with all the other stuff? It doesn't do nothing except make it go away.
You mean, why did I write this second line?
Well, yeah, because you figure
Just to make it really clear what's going on.
Oh, okay.
Yeah. So anything I show you, you've always got to show me some work. But anything I show you, the more it makes sense to you, the quicker you should be able to do it. Right? The more you understand, the less you should have to do. When I show it on the board, I'm going to hopefully show more steps, so that everybody can see where everything went and came from. And not a damn thing wrong with just not even doing the second step. That's awesome. Nothing wrong with that, as long as you don't try to do it when it's not an equation. And so, finish out what happens. Yeah. Add that over, subtract it over, so x is 6/7. Cool. So that's old news. So you guys have your own way of doing that kind of problem, right? Very apparently. Now, what happens when I have variable expressions down and not just numbers? Right? So let's see if I had something like this here. Now, not surprisingly, you should know the answer to that would be we do the same damn thing. Right? That's my point with variable expressions is they're just numbers. They're numbers we don't know yet, but they're numbers, so they have to act the same way. So what did I do here first? Yeah, I found the least common denominator, made sure everybody had it. Right? So what do I have to do first here? Since it's not numbers I can just see real quick. What do I have to do first there? Fact. Kick ass. So what do you get here?
X plus 3, X minus 3.
Not surprisingly, it's those. It's going to happen most often. It's going to be like that. Yeah, he's got everything he needs, right? What's he need?
X plus 3.
X minus.
X minus 3. Kick ass. And now, much like this, I can multiply both sides by 16. What can I multiply both sides there by? X plus 3, X minus 3. All right, so saving a little time. If I multiply both sides by X plus 3, X minus 3, what's going to happen in each term? That's going to cancel with that. That's going to cancel with that. And over here, same thing. Now, a quick question. From the very beginning, when I wrote that, what values of X was I not able to use? Can anybody see, like, what would freak this guy out?
X3.
Yeah, X could not be 3, and X could not be negative 3, right? So if I work this problem out and I get them as answers, what do you think I got to do? Yeah, so if I get X equals 3 as the answer, the actual answer is no solution. And the reason math does that is, if X is 3, what did I just multiply both sides by? 0. Am I allowed to do that? No. So math gives me a little, it's like a gentle, dude, you weren't really allowed to do that. It waits until I get here and says X equals 3, and it's just, that's its way of saying, oh yeah, you weren't really able to do what you did. I didn't want to make a big deal of it back then. But here, these cancel out. What am I left with? X. Kick ass. And look how much better that looks compared to what it looked like to begin with.
Yeah.
Cool. And now that's easy. All right, it's going to come out with a really nice. Yeah, so if I add 12, I get 18. If I subtract 3x, I get x. X is 18. Is that an okay answer?
Sure.
The only answers that would not be okay, again, were 3 and negative 3. If I got one of those, I've got to throw them out. It's what's called extraneous solutions. And most often, almost all the time, it's not math's fault. It's because we did something that we didn't know was illegal at the time.
Wait, so if X equals 3 or negative 3, then it's no solution?
Exactly. Or if there were several answers, you'd cross the ones out that make one of these undefined.
It's whatever's on the bottom.
Exactly. The only thing that would make a fraction undefined is if the bottom was 0. So that's why I really only care about the bottoms.
Plus 4, minus 4.
Then it would have been 4 and negative 4. Exactly. Good. So that's the basic idea behind section 7.6. So here, you guys try this one. Not using y, Jeff. All right. Oops. Oh, shoot. Alright, I'm trying to use different letters and stuff. Make this X up here an M, so they're all M's. Otherwise, it's a little freaky. So call me over if you need some help.
Hey, should we factor that middle bottom one first?
Dude, yes. Any bottoms you can factor to do, so you can see what it's got.
That was too easy to figure out.
Good, yep, exactly. So just to remember, be real careful about that. The minus there. Yeah, so everything on the bottom cancels if you multiply by it on both sides. And then you're just left with the tops. And you gotta be careful because that negative, it's gotta go to both. You see the minus 3 and then the minus negative 1. So the negative's gotta go to both of those. So it distributes, yeah. Cool. Yeah, 2, 6, 1. And do me a favor, try never to have more than one equal sign in a row. Yeah. It's just a little convention. Oh, right here, that negative has got to go to both. It makes this a plus 1. That minus right there. So minus 3 and minus negative 1 is real easy to miss that. Yeah. Okay. So this answer, considering I just pulled this out of nowhere, the answer is not necessarily going to be, 2. It's going to be probably something like an uglier fraction. All right. So taking cross suggestion, what do you get when you factor this here? Thank God we get the same things we got out there. All right. Makes us a lot better. So, what does he need? All right, we stop right there. So now I can do what? Since I have an equation? That's right. You can multiply. Oops, I forgot this thing. Multiply by the LCD, and all these are going to cancel, right? So if I multiply by m plus 4, m minus 9, if I multiply that to everybody, go away here. All right. This times this cancels, this times this cancels. What really sucks is when somebody multiplies that to the top also. It's dead. It canceled with these two things, right? Let it go away. On that side, they cancel, so then I end up with the tops. So what do I get? I get
2m minus 18 minus 3m plus 1.
good. Minus negative 1 is plus 1. Any negatives in the middle of these have to go to both the things on the top. It's got to distribute across. Equals the gas. Yeah, so if you add 6m, you get 6m, subtract, you get 4m. Subtract 12, you get negative 30, you get negative 29. And then divide by 4, so you get m. Negative 29 over 4. Okay. Coolness. But at least that wasn't what? What values would we have to be careful about? 9 and negative 4. Good, right? Those are the two things that would make the bottom undefined. I mean, make the thing make the bottom 0. Cool, cool, cool. All right. Not too bad, right? Yes.
The top of 3 and minus 1, did that get multiplied by?
It was LC.
Oh, yeah.
So he already had everything, right? So I didn't have to give him anything. He already had the m plus 4 and the m minus 9. So I didn't have to multiply him by anything.
How do you have the m plus 4 on the top? I'm talking about 3m minus
Here. No, here.
Yeah, there.
Okay? So he's already got, from the beginning he had both things. So I don't have to give him either one. He definitely was missing an m minus 9, right? He didn't have an m minus 9 yet.
Okay.
He didn't have an m plus 4 yet. He had both of them. So I don't have to give him anything.
Oh, you're talking, okay. I'm thinking 3m minus 1 is supposed to have something extra, but
No,
It's-
definitely
You're
not.
looking at the
You're
denominator.
trying to make all the bottoms the same.
Okay.
So they have the
Alright.
lowest common denominator. You're trying to have
I
have
think
all
I got
the same.
confused because you had the 2 times the m minus the 9.
Exactly, because I had to multiply him by m minus 9 because that's what he was missing.
Okay, and since that second term there already has it on the bottom, you don't need
Don't need it.
Okay.
It's
that's
just
right.
like
All right.
if I was doing 1/4 plus, what do you got, Jeff? 7/12 minus 1/3. So it's the same thing, right? It's almost the same problem in a way, because what's the middle term? It's 4 times 3. So of course he's missing a 3, he's missing 4. What's he missing? Nothing. He's already there. But I see this all the time. It makes this problem so much harder than it has to be. Don't give him anything. He's already got everything.
Okay. I was confused with that denominator. I see what you're saying.
Cool.
Thank you.
You still have to multiply by that negative.
Exactly. That negative's got to come through when I kill the bottom. Exactly. Good. All right.
Explain that negative one more time. We said the negative has to come through.
Yeah, the negative's got to come through. So, for example, I mean, if I had, this is going to seem silly, but oh well, minus 2 plus 1 over 5. This is not 3 minus 2 plus 1.
Right.
That's not the same thing I just wrote over 5, right? Do you guys see that? Because it's got to be 3 minus 2 minus 1. I got to subtract this number. And of course, this number is 3. So then it would just be 0, of course. But the minute I write it like I have to with the variable, I have to write a variable like this. Because I can't combine m's and 1's. So I have to write them separately. But then everything looks different to us. But if I wrote 3 like this, I'd have to do that. 3 minus 2 minus 1. So it's this minus 3m minus negative 1. That's why it's a plus 1. Cool. So that minus in the middle, you've always got to be careful about that. Okay, cool.
Thank you.
By the way, the dude that was here, so that was my dean. Right? So this is, I got tenure a few years ago. It was every 3 years I had to get evaluated by my dean and 2 of my colleagues. And then I'm evaluating somebody else's semester too, so we kind of evaluate each other. It's crazy.
You gonna handle this?
No, Carl, sorry.
All right.
I'm not really sure what you would do.
Extra credit.
No, that would be bad. That would be bad. He'd say it was okay until he sent one of his students out. I was going to say, one of his goons came out just to make sure. So we had to fire him. All right. So let me show you a problem that looks easy. And actually, this is from, let me show you a problem from earlier that I always forget about until I assign it.
It looks easy, but it's not. Is that what you're trying to say?
Totally. It's not.
Missing a minus one.
Hmm?
How do you?
So just to save some of you guys from yourself, the mistake I get is somebody tells me this.
I was just about to do that.
That is so bad. So, and then I'm going to be a real dork, and over here I'm going to say, so 3/5 equals 3 minus 1 over 5 minus 1 equals 2/4. Neat. Or even better, 1 over 2 minus 1 minus 1, 1/2 equals 0. So you can't add and subtract something to the top and bottom of a fraction. It's the only thing you can do to the top and bottom of a fraction. Multiply or divide, right? And you said that to me earlier. And now here you are about to subtract. I mean, right? So what you got to realize is if x is 7, what's this?
6.
If x is 7, that's 6. What would the LCD be then? 7 times 6. They're missing each other. So the LCD here is going to be x times x minus 1. They're missing each other. So what's this guy need?
X minus 1.
Yeah, exactly. He needs the whole x minus 1, and he needs an x. Or she. I don't know what they are. I'm not sure where to look. The biology of mathematics. So what you get now? Notice something. Now I won't say anything. I'll wait. So what's the answer? What do you guys get? Anybody? You guys are working on something.
Isn't it 2 x minus
The
2?
bottom's the same. X,
Good.
X squared minus 4.
What are you guys doing? So on the bottom you're going to have x times x minus 1. What do you get on the top?
Minus x. Right?
2x.
The top is 2 x minus 2.
It's 3x.
Yeah.
Good. Yeah. So you get
5x.
5x minus 2.
Like I said.
Of course, when there's like 30 people talking, don't feel bad if I can't pick you out.
So why couldn't you eliminate the bottom on this one?
Good. Why? I kind of did that before. I was thinking, don't do that, and then I did it. I didn't want to put anything on the bottom because I wanted to see if anybody said the bottom was away. Why?
Was that finished?
No.
Not yet.
X.
Why is it finished?
Ah,
Can we distribute X in the bottom?
Can I factor the top?
no.
No. There's no way I can get either one of those to show up here. Now, why is there still a bottom here?
Because there wasn't another side.
Good, because there's no other side. You don't have another side to balance out.
That's right.
See, it gets so, you got to be really careful. It's an equation or a fraction that lets you multiply, because there's always, as long as you do it to both sides,
Why
it
does
balances.
everybody do that?
Well, your brain gets excited about killing stuff, right?
That's true.
Or mine does, and that's how I say it. Yeah.
Why we couldn't distribute X over X minus 1?
It's not that you can't. It's not that
We
you
can?
can't.
Okay.
You totally can. It's just why.
Okay, so
Because the last thing you do is make sure you can't cancel anything.
Yeah.
And if you multiply that too early, you might miss something that you could have canceled. So that's why I just tell people don't even multiply it out, just so you can make sure there's nothing that would go away. But it's not wrong if you do. It's not wrong.
So if we would have X by itself in the top, then we'd be able to cancel. That's
Exactly.
Okay.
If that minus 2 wasn't there, I could have killed the x.
Right.
Because then it would have just been multiplication up top. Cool. Right? Looking at it doesn't make it go any faster. Yeah.
So when you were just saying with that x, you could cancel those two x's there, the 5x and the x underneath?
Not right now.
No.
Not the way it is.
Because you have the x minus 1 next to it?
So this is done. But if it was this, why can I kill those x's? What's the only operations in this thing? 5 times x divided by x times this.
Because the 5x minus the 2 is considered one, because they're together.
It's really just because what's the operation on the top here?
Subtraction.
Subtraction. Division can't cancel parts of subtraction. It can't. That's it. So I can't cancel these x's because division is not the opposite of subtraction. That's it. That's all that has to be said, because that's it. Here, I can kill those, because division is the opposite of multiplication. So that's why I totally can kill these guys. Over there, no, I can't break into that minus. You guys good? Well, several of you are still going to do that anyway. Yeah.
That's what I was saying earlier, though. Isn't it 5x minus 2, like, considered one term?
So sometimes it's considered one term. Like the x minus 1 on the bottom, I look at that as one number.
Yeah, but it's separated by parentheses, so that tells you it's this times this.
Yeah, true. Because it's part of a product. It's definitely, you want to look at it as one number.
Doesn't the subtraction sign up top connect the whole thing, though? Is that?
I'm not sure what you mean.
Well, because you're saying you can't get rid of the x because of the minus 2.
Yes.
But the minus 2 is minus whatever 5x is.
Okay.
So I'm thinking in theory that
No. So,
they're still dividing.
you ready?
You just can't divide the 2. Do you?
So can I reduce this?
No.
No.
Even if I can write 3 as 5 minus 2 or 5.
No.
That'll shake some people's world up a little bit. You can't kill those 5s, can you? It's because of the variable. The variable does not let me... 5 minus 2 is 3. Hell yeah, I'm not going to write 5 minus frickin' 2. I'm going to write 3, because that's what the hell it is. But what the hell is x minus 2? Or 5x minus... I don't know, shit. But then that makes us think, oh, it's got to act differently. No, it's just because I can't simplify it. But there's no way I could take 3 and make it this and go, yeah, equals negative 2.
No.
You owe me $3.50. No, you owe me $2, sucker. No. I'm so happy I got it. That was horrible. You guys quit. I got a little caught up.
Because you don't know what x equals, right? It's the other part of why you can't do it.
You can't combine those here because I don't know what x is exactly. It's not like terms with the two.
Yeah.
Right? So that makes us feel like things should be different somehow, but they're not. This is exactly the kind of silly example to keep in your head. There's no way that would make any damn sense. If it does, come see me immediately. So there's no way that this would make sense at the same way. There's no way. It makes as much sense, which is none. Yeah.
I have a question.
Yes.
I got confused last time. If we have x squared divided by, let's say, 2x. Yes.
So if you really want to, if you want to see it all the way out, what's x squared mean?
X times
X. So what cancels? Or better, don't even do that. Just say I've got 2 x's, so one of them cancels, so I've got 1 x left on top, right? So if I have x to the 7th over 4x to the 11th, here's where things get interesting. How many x's would cancel?
1x.
How many x's would cancel?
7.
How many would be left?
Negative 4.
There would be 4 left. Where?
On the bottom.
What's on the top? Beautiful. Because another way to write this is x7 over 4, x7, x4. Is that, you guys see that? So then those go, what's x7 divided by x7? Something divided by itself is 1. That's why there's a 1 up top. Because that's what's left when you kill it. So I don't even do 7 minus 11 is negative 4 and then you got to flip it. I just go, well, there would be 4 left on the bottom. Bam. Right? 7 would die, 4 would be left on the bottom. Where there's more, that's where they would be left, right? My army's got more than yours. There's some of us left. I've got Game of Thrones in my head now. We got the little dude. You're in trouble. Okay. One more that looks a little bit weird. I like that one. I like it. This is true. Good. It's an equation, so you're allowed to do what? You can multiply by whatever you want to eventually. What do you kind of want to do first?
Make it
7x.
Yeah.
7x.
So he needs an x on the top and the bottom. He needs 7. And the 0 doesn't matter. You can give him 7x all day long. He's still going to be a freaking 0, right?
Yeah.
So now you're allowed to multiply both sides by 7x. I just put a 7x next to everybody. 0 times 7x. 0. 7x's go away, 7x's go away. I get
X squared.
x squared.
49.
So you will get some problems in here where you get these squares. So if you get a square, you've got to get everything on one side, make it 0, and then factor. We know that. So that's going to happen in this section in a few different ways. And this is one way it's going to happen.
X plus 7, X minus 7.
Are both answers okay? Yes, because the only answer that would not be okay is, if that was true, then that would be bad. What's the only thing that makes this 0, if I make x 0? Yeah. What makes x 0?
0.
0? That's crazy. Right? So if I would have gotten 0 as an answer, I'd have to throw it out. I didn't. People freak out because they see the 7 and they go, well, then you can't have negatives. No, this is just always 7. What the hell? It's fine. Yes?
Could you just take the square root of 49? Like if you added 49 to it?
Cool. I love it. Square root plus or minus. Don't forget the plus or minus. Kick ass. But not all of them are going to be like that. There are going to be some that x squared plus 4x plus, you got to actually truly factor it. But this way, if you want to solve it that way, nothing wrong with that. It's awesome. Yes?
Okay, let's say you got it to 0. X is 0. Then what do you say?
Yeah, if for some reason it was like this, you would just do that. Or if your only answer was 0, you cross out and say no solution. Yeah. You've always got to tell me what the answer is. If there is no answer, you better tell me. Yeah. Cool. Sorry. All right. Let's see.
One more call.
Trying to think about. Well, 7-7 is the word problem section with these. Oh yes, I just said that. And then somebody remind me, I think we jumped to chapter 12. That's just how our curriculum is. So what's in our future is, I think I just said this earlier, are radicals. Square roots, cube roots, fourth roots, whatever roots. It just never ends. Huh? Depending on your teacher. I think most of them did like a really quick overview. Didn't do much with it, right?
I did a little bit.
Okay. So we're going to get deeper and we're going to solve equations with radicals in them. Yeah. So yes, that's plenty for today. Did anybody come in late and not get their quiz back? For us. This is the curved grade.
Okay.
And that was your average between the test and the quiz.
Okay.
Yeah.
Thank you.
How many? Make corrections for that.
I don't know the correction here for this one, but this one, I'm understanding that it's shaded towards the 0 and the 1.